You got to have the natural killers. Natural killer cells are a type of lymphocyte. Of all lymphocytes, they make up about 2% of the lymphocyte population. And so they're not very common, but here's why we're talking about them right now. They are going, they go around, they're nonspecific. So they're not responding to a specific antigen. They go around and they identify cells that lack what? MHC1. Now, I just told you that everybody has MHC1 except for red blood cells. And there must be some reason why natural killers do not attack red blood cells. And I don't know what that mechanism is, but natural killers do not attack red blood cells. But all your other cells are supposed to have MHC1. And sometimes certain pathogens, like, good Lord, viruses. Some viruses are like, dude, I'm going to disable your Facebook account so that you cannot post information about my presence on your Facebook, because the police might come and, like, arrest me if you post information about my presence. So they make your MHC1 go away. Sometimes cancer cells also have an MHC1 platform that is not functioning. And so cancer cells can sort of hide because they're not posting information about what's going on inside of them. So natural killers come along, and they're like, something's missing here. And they initiate the tragic yet valuable process of apoptosis. Apoptosis is cell suicide. And suicide. I'm going to add another word because I can. Controlled cell suicide. Now, cells die all the time, and they're going to die. I mean, we have like 10 trillion of them or something like that. Like, it's ridiculous how many cells you have. And they're going to get old. They're going to wear out. If they die while damaged, it's called necrosis. And the outcome is like cell guts everywhere. And think about what's in a cell. Like, you have digestive enzymes, you have like other enzymes, you have all sorts of stuff in that cell that's held away from everybody else by the cell membrane. During the process of necrosis, the cell pops and all that stuff goes out into the interstitial fluid, and that's like a sad story that's going to affect lots of surrounding cells. It's going to be bad. So the body has a process by which apoptosis can be initiated, and that actually leads to, it's chemically stimulated, and there are two main molecules that facilitate this. There are granzymes and perforin. Perforin perforates the cell. It pops holes, makes holes in the cell membrane of whoever is being targeted for apoptosis. So if you put holes in the cell, you can imagine that fluid is going to, you're basically going to pop the thing. Granzymes initiate this cascade of chemical reactions that tell the cell, okay, we're shutting things down. We're going to put away all the digestive enzymes. They're going to go in this pipe. We're going to disable any weapons or any machinery that we have in here. It's chemicals that shut things down. So the natural killers come along, and they're like, dude, where's your MHC1 platform? And the cell in question is like, I got nothing. I don't know where it went. Somebody's in here, and they took it, and I don't know what to do about that. And the natural killer's like, dog, it's a sad day for you. It's time for apoptosis. Natural killer barfs out some perforin, barfs out some granzymes. All of those things go into the targeted cell. The targeted cell goes through the process of popping. And it was a sad day. But, dude, let's do that rather than necrosisize, because then that's going to be even a bigger mess. All right. Dude, natural killers, they're incredible. The last thing I want to talk about is one more generalized strategy for popping bad guys or dealing with bad guys. It's kind of similar to apoptosis, but we'll talk about that in a second.